You think magnets should be easy to explain. Two objects pull together, or they push apart. Invisible force. End of story. That is the picture you carry. A simple one. You imagine magnetism as one of those ordinary facts of the world that becomes less mysterious the moment someone smarter names it. North Pole, South Pole, magnetic field. But naming something is not the same as explaining it. That is the discomfort. Because the moment you ask the wrong question, the real question, the confidence disappears. Not, what do magnets do? You already know that. The question is, why should matter behave this way at all? Why should one piece of metal reach across empty space and affect another? Why should the universe contain this kind of interaction? Why this rule? Why this structure?
And this is where even physics becomes careful, because Feynman could explain how to describe magnetism. He could explain how to predict it. But when people demanded the deeper why, he refused to pretend the mystery had vanished. That is the part most people miss. You think science removes mystery? Sometimes it only makes the mystery sharper. The illusion of explanation. You think you understand magnets? You learned the words early: North Pole, South Pole, magnetic field. They sound complete. They feel like answers. So when two magnets pull together or push apart, you don't feel confused. You feel informed. But pause for a moment. What did those words actually give you? Magnetic field tells you something exists around the magnet. Force tells you something is causing motion. But neither tells you why this should be happening at all. The words describe behavior. They do not explain its existence. This is the subtle mistake. You replace mystery with vocabulary, and the moment you can name something, it begins to feel understood. But nothing fundamental has changed. Imagine someone asks you, why do magnets attract? And you answer, because of the magnetic field. You have not gone deeper. You have only renamed the same phenomenon. You have taken the effect and wrapped it in a new word. The attraction is still there, unexplained. This is what Feynman was pointing at, not ignorance, but honesty, because physics is very good at describing patterns. If you place two magnets near each other, we can predict exactly how they will move. We can calculate the force. We can map the field. We can build technologies that rely on it. But the deeper question remains untouched. Why should space behave this way? Why should matter have this property? Why should such a force exist at all? The moment you stop accepting the labels as answers, the confusion returns. And it returns stronger than before, because now you see that the explanation you trusted was never really an explanation. It was a description that felt complete, forces without contact. You expect interactions to require contact. Something pushes something else. Something hits, presses, collides. That is how cause and effect feels. Direct, physical, understandable. But magnets do not behave that way. Two pieces of metal sit apart, separated by empty space, no visible connection, no bridge between them, and yet they move. One pulls the other closer or pushes it away. Something is happening across the gap, and that gap matters because it forces you to confront a question your intuition avoids. What is in the space between them? You might say, nothing. That is what empty space feels like. But if it were truly nothing, nothing could happen across it. No force, no influence, no motion, and yet the motion is there. The effect is real. So the space cannot be what you think it is. Something about it allows interaction. Something about it carries influence. But this is where your intuition reaches its limit, because you cannot see it. You cannot touch it. There is no physical thread connecting the magnets, and yet something behaves as if there is. This is deeply uncomfortable. Or because it breaks the simplest model of reality, that objects only affect each other when they meet, magnets refuse that rule. They act at a distance, not by touching, but by existing in a space that is not truly empty. And once you accept that, a deeper question emerges. Not just how magnets interact, but what kind of reality allows interaction without contact. The problem of why. You think why is a fair question. In everyday life, it always works. Why did the glass fall? Because someone pushed it. Why did the door open? Because you turned the handle. There is always a cause behind the effect. So you carry that expectation into physics. You see magnets attract, and you ask why. It feels like the most natural question you could ask, but this is where something subtle happens. Physics does not answer why in the way you expect. It answers how. It tells you how magnets behave, how the force changes with distance, how fields describe the interaction. It gives you equations, predictions, patterns. But when you ask, why does this force exist at all? Physics becomes quiet, not because it has failed, but because the question itself may be misplaced. You are asking for a deeper cause, a reason behind the rule. But at some point, the rules do not have deeper explanations. They are the foundation. Feynman was careful about this. He refused to pretend that saying it's due to the magnetic field was a real answer to the deeper why, because that just shifts the question. Why does the field exist? Why does it behave that way? You can keep asking, and each time the answer becomes another description and another layer of how, but never a final reason. So the discomfort grows because you begin to realize something unsettling. Your expectation that everything must have a deeper explanation may not match how reality is structured. At some level, physics stops explaining and starts describing the rules that exist without reason. And once you reach that level, the question why does not disappear. It simply stops having an answer in the way you expected. Fields replace intuition. You try to imagine what connects the magnets, some invisible thread, some hidden substance stretching between them, because your mind wants something physical, something you could, in principle, point to. But physics does not give you that. Instead, it gives you something more abstract, a field. The word sounds simple, but it hides a shift in how you must think. A magnetic field is not an object. It is not something you can hold or isolate. It is a way of describing how space behaves around the magnet. At every point in space, the field has a value, a direction, a strength. And that value tells you what would happen if another object entered that space. So instead of saying the magnet reaches out and pulls the other one, physics says the space around the magnet is structured in such a way that another magnet will experience a force. This is a different kind of explanation, not objects acting directly on objects, but space itself having properties, and those properties determine how things move. This is where intuition begins to fail completely, because you do not experience space that way. To you, space is empty, a background, a place where things happen. But in physics, space is not passive. It has structure. It carries information. It tells matter how to behave. The magnet is not sending something across the gap. The gap itself is not empty. It is part of a field, a structure that already exists, shaping the interaction before anything moves. So the force between magnets is not a mysterious action at a distance. It is the result of a deeper rule. That space itself is organized in a way that produces that force. And once you accept that, the question changes again. Because now you're no longer asking how magnets interact. You're asking, why does space have this structure at all? Charge, motion, and relativity. You think magnetism is its own kind of force, separate, distinct. Something that exists alongside electricity as a different phenomenon. That is how it is often taught. Electric force, magnetic force, two categories. But that separation is not as real as it seems, because when you look deeper, magnetism begins to blur into something else, something more fundamental. Electric charge. Take a simple situation. A stationary electric charge creates an electric field. Nothing surprising there. But now let that charge start moving. The description changes. To one observer, it is still just a moving charge. But to another observer, moving at a different velocity, the situation looks different. What appears purely electric in one frame of reference begins to show magnetic effects in another. This is where intuition breaks again. Because magnetism is not an independent force in the way you imagined. It is a consequence of electricity combined with motion. And more deeply, it is tied to the structure of space and time itself. Relativity enters quietly here. The same set of events can look different depending on how you are moving. Distances change, time intervals change, and what you call electric or magnetic depends on your frame of reference. So magnetism is not a separate phenomenon. It is what electricity looks like when observed from a different perspective, which means the force you thought was mysterious on its own is actually part of a deeper unity. Electric and magnetic fields are not two things. They are two aspects of the same structure, a single electromagnetic field, and this should unsettle you. Because it means magnetism is not just a property of magnets. It is built into the way space and time are woven together. The interaction you see between two magnets is a surface effect of a deeper geometry. a rule embedded in reality itself. And once you see that, the question shifts again, not just why magnets work, but why space and time allow such relationships to exist at all. The collapse of common sense. You trust your intuition. It tells you how the world should behave. Objects should touch to interact. Forces should have visible causes. Space should be empty unless something is in it. These ideas feel so natural that you rarely question them, but magnetism does not follow those rules, and neither does much of modern physics. The deeper you go, the less your intuition helps you. Because your intuition was not built to understand reality, it was built to help you survive at human scales, at low speeds, in environments where approximations are good enough. But magnetism and the physics behind it does not operate at that level. It operates at a level where space has structure, forces act without contact, electricity and magnetism merge depending on motion, and the same phenomenon can appear different depending on how you observe it. None of this feels natural. Because your brain was never designed to think this way, it simplifies. It creates solid objects from empty space. It creates clear causes from complex interactions. It builds a stable picture from unstable processes. And that picture works well enough for daily life, but it breaks the moment you look deeper. Magnetism exposes that failure. It shows that what feels obvious is not what is real, and that what is real may not feel understandable at all. So the discomfort you feel is not a sign that something is wrong with the physics. It is a sign that something is limited in your way of thinking. Your intuition is not a guide to reality. It is a shortcut. And once you see that, the final step becomes unavoidable. Because now the question is no longer about magnets. It is about the limits of explanation itself. The honest end of explanation. You expected an answer, a final reason. Something that would close the gap between what you see and what you understand. But that closure never comes. And this is not a failure of physics. It is a boundary. Because physics can take you very far. It can describe magnetism with precision. It can predict every movement, every force, every interaction. It can show you that magnetism is not separate from electricity, that it emerges from motion, that it is woven into the structure of space and time. It can replace your intuition with something more accurate, but it cannot answer the question you keep asking. Why does the universe have these rules at all? Why should space behave this way? Why should charges exist? Why should motion create magnetism? At some point, the chain of explanation stops, not because there is nothing left to say, but because what remains are the rules themselves, and rules are not explained by deeper rules forever. Eventually, they are simply described. This is what Feynman refused to hide. He could have given you layers of explanation. He could have buried the question under more concepts, but he chose not to, because doing so would create the illusion of understanding. Instead, he stopped at the edge and pointed to it, the place where explanation ends and reality simply is. This is the unsettling part. Not that magnetism is mysterious, but that the universe itself may not provide the kind of answers you expect. There may be no deeper why in the sense your mind demands, only structures, patterns, rules that exist without justification. And the more honestly you look, the clearer that becomes. Not everything is explainable in the way you were taught to expect. Some things are only describable. And beyond that, there is silence.